Hello everyone, in this video let's try to understand what is this particular AUC and ROC curve, and also let's try to understand how is it useful for us. Okay, so in order to understand these things, let's try to take a simple example that we have taken in logistic regression, and that is based on number of hours studied in a week, we wanted to predict whether the student will fail or pass. And the data points that we are seeing over here are looking like some real world data. That is because here, if we carefully observe, there are few students who are studying more than 4.5 hours, even then failing, and there are some students who are studying less than 4.5 and they are passing. So this is some kind of real world behavior. That's why I have written some few points. Okay, so for such kind of data set, if we are trying to apply logistic regression, what we'll try to do in logistic regression, we'll try to draw some S-shaped curve. And what is this S-shaped curve? If you guys remember the hypothesis of logistic regression, it will be y equal to sigmoid of theta naught plus theta 1x. So this is our hypothesis in case of logistic regression. And if you guys remember, this y cap or the output of sigmoid will be ranging in between 0 to 1. And while discussing logistic regression, I just explained it like 0 to 1 is kind of a probability score, and if it is greater than 0.5, we'll say it as like the predicted class is 1, and if it is less than 0.5, we'll think it as predicted class is 0. But actually there the point is this 0.5 is our threshold. But do you guys think always this threshold will work good? That means every time 0.5, do you think will it work good? Basically, it will not be working good, because sometimes it can happen that more than 0.5, 0.75 might be working good for some specific example. Okay, and there can be some other use case where 0.3 is more useful. So that's why it is really important in order to find the best threshold for the model that we are having. Okay, in order to find the best threshold, previously in the logistic regression, we didn't tell any specific thing like these are possible thresholds and how to select that and all. Just I wanted to explain the concept over there. That's why I explained simply. But the thing is, we need to select the threshold, and it is also kind of a hyperparameter that we need to decide. So we can't decide directly. So for that, we can use something called as ROC curve. And what is ROC full form? Receiver operating characteristic. And with the help of this particular ROC, we can able to find what is the best threshold for our model. So that is the use of ROC. Before going on to the working of ROC, let's try to understand one thing. That is, if I wanted my model to predict everything to be 1, then what should be my threshold? Please pause the video, think for some time and comment down in the comment section. Basically, now let's see what should be the threshold. If you wanted to predict everything as 1, then whatever value given by this particular sigmoid, we just need to tell that it is class 1. So in order to do that, we can use some threshold which is very less value, that is slightly lesser than 0. So let's say if you are taking some threshold which is slightly lesser than 0, then always the output that we get from sigmoid will be greater than that one, right? So that's why if threshold is slightly less than 0, then it will make every prediction to be 1. And similarly, if we want every prediction as 0, then what should be my threshold? My threshold will be slightly greater than 1. When the threshold is slightly greater than 1, then what will happen? Then the value that we get from this particular sigmoid function is in between 0 to 1 only. So it can never cross the value which is greater than 1. That's why it will always give us predicted value that is 0, or always it will be giving us 0. Okay, so these two things, if we have idea, then you'll understand the ROC curve more clearly. Okay, so that's why I'm telling these things. So I hope these two things are clear. If it is not clear, just rewind back and check it out. And now we have seen what is this table and what is this confused matrix. If you don't know this, please refer to the previous videos, then you'll get some clear idea. And now let's check this particular true positive rate. And what is true positive rate? True positive rate is same as recall positive, where the formula is true positive by true positive plus false negative. And similarly, false positive rate is false positive by false positive plus false negative. Sorry, this is true negative. Okay. This will be my true positive rate formula, and this will be my true negative rate formula. Ideally, for some specific model, what should be the true positive rate? Means it should be greater or lesser. Basically, true positive rate should be greater. And what should be the false positive rate? False positive rate should be lesser. And why is that? Because true positive means that it is telling about correctly classified points. So we wanted to increase the correctly classified points, right? That's why we expect model to have more true positive rate. And similarly, we expect the model to have less false positive rate, because false positive is signifying about misclassified points. I hope you guys understood why true positive rate should be more and why false positive rate should be less. Now let's see in which case can we get this particular true positive rate to be 1 and this particular true positive rate to be 0. And similarly, in which case can we get this false positive rate to be 1 and false positive rate to be 0. Let's try to understand this. So basically, in order to get this as 1, what should be 0 in this particular true positive rate formula? If this particular false negative is 0, then obviously these two will be equal and true positive rate will go to 1, right? And similarly, when in this particular equation, when it can go to 1, when true negative is 0, at that particular time it can go to 1. Okay. And similarly, when it can go to 0, when true positive is 0, then it can go to 0. And similarly, when this can go to 0, when false positive is 0, then it can go to 0. Basically, if you wanted to make this particular fraction 0, then we should make the numerator to 0. And if you wanted to make this fraction to 1, then this particular extra value apart from this numerator value, that we need to make it as 0. So that is what we are trying to do over here. So if you want to make false negatives to 0, that means there should be no negative values. So if there are no predicted negatives, then there is no possibility that the model has false negatives, right? So that's why what we'll try to make, we'll try to make all the predicted values to be 1. And how we can do that? So if you want everything as 1, every predicted value as 1, then what should be my threshold value? My threshold value will be slightly less than 0. Okay. And similarly, in the true negative, if you wanted to make true negative also 0, then always we wanted the predicted value as 1 and the corresponding threshold value should be less than 0. Okay. And similarly, if you wanted to make true positive and false positives to 0, then what we can do? We can do, or we can make the model such a way that always the predicted value is 0. Okay. In both these cases, if we make the predicted value to be 0 always, then what will happen? Then there is no chance that like the model has true positives or false positives. That's why in order to make this, what should be my threshold value? My threshold value should be slightly greater than 0. That we have already seen over here. If you want every predicted value as 1, then we should have threshold less than 0. And if you want every predicted value to be 0, then we should have threshold greater than 1. This is about true positive rate and false positive rate. And ROC curve is like graph between these two, that is true positive rate and false positive rate. Basically on x-axis we are having this true positive rate, on y-axis we are having this false positive rate, and between these two we are drawing the ROC curve. And like let's say when true positive rate is 1 and also when false positive rate is 1, we'll be having the point over here. Basically true positive rate is 1, I'm considering this one, and when false positive rate is 1, I'm considering over here. For which threshold it is like that? For threshold which is slightly less than 0. You can think here the threshold is slightly less than 0. And when we can have both zeros, that means when we can have true positive rate and false positive rate to be 0, 0, that we can have when the threshold value is slightly greater than 0. Sorry, it is 1. Okay. So when the threshold value is slightly greater than 1, then we'll have both of these to be zeros. Okay. When the threshold value is slightly greater than 1 or little bit greater than 1, then my true positive rate and false positive rate both will be 0. And if my threshold value is less than 0, then my true positive rate and false positive rate both are 1s. So these are two extreme cases. And if you guys remembered, the true positive rate to be higher and false positive rate to be lower. So in this case, both true positive rate and false positive rate is high. So we don't want this kind of model. And also here, if you observe, here both true positive rate and false positive rate both are less. So we don't want this model as well. We want some intermediate model whose values might be ranging something like this. Okay. So for different thresholds, we might get like different true positive and false positive rates, and the graph might look something like this. So let's say this point is here, we might be having false positive rate as 0.8, but the true positive rate is still 1. And here, let's say we are having false positive rate as 0.6 and true positive rate is still 1. And here we are having false positive rate to be, let's say, 0.4 and true positive rate is 0.8. And here, let's say it is my false positive rate is 0 and true positive rate is 0.6 and the 0, so let's say 0.4, and this is 0, this is 0.2. And whatever coordinates that I'm writing, these are referring to true positive rates and false positive rates. And for this, the thresholds can be different thresholds. Let's say here we are having threshold of 0.3, and here we might be having 0.5, and let's say here we have 0.6, and here I'm having, let's say, 0.75. Like that, for various thresholds, I'm getting different values like this. Okay. In all of these points, which is more important, that we need to understand. So based on the problem that we have, that we need to decide. So basically, as I said, the main thing that we need to look is, we need to make sure that true positive rate is as high as possible and false positive rate is as low as possible. So where is that happening? Let's say here, if you observe, the true positive rate is 1, which is good, and false positive rate is 0.6, which is not so good, but it's okay. It is not 1, right? We can be happy with it. Or if we see this one, this is also good. The false positive rate is 0.4, whereas true positive rate is reducing a bit, that is 0.8. So we can say this is also good. Whereas here, if you observe, the false positive rate is 0, but true positive rate is also very less, that's 0.6. So we might choose something like this or this model, which will be giving us good results. Okay. So like that, we need to find the best threshold based on the ROC graph that we are having. So if we combine all these points, then my ROC curve will look something like this. Okay. And this ROC curve that we are drawing, this is for logistic regression, right? And same binary classification problem we can even solve with so many other machine learning algorithms, right? So let's say I'm solving the same problem with the help of SVM. SVM is some other machine learning algorithm. So with that, I'm trying to solve the same problem. So let's say in that case, I'm getting these green points as my coordinates with the change in thresholds. Okay. So by changing my thresholds, these are all the points that I'm obtaining. If I'm connecting all these points, then I'll be getting a graph something like this. Okay. Now we have ROC graph of logistic regression, and also we have ROC graph of SVM. So these both graphs are on the same thing. Now which algorithm is good for this specific problem? Like there can be multiple binary classification algorithms, right? But you might be interested in selecting only one algorithm, or we can only select one algorithm, right? So in order to find which one is the best algorithm, for that we need to use something called as AUC, that is area under the curve. Area under which curve? Area under this particular ROC curve. Whichever algorithm is having more AUC, that will be the best model for the problem that we are having. So here, if you observe, for the logistic regression, this yellow one, the yellow one is covering this much amount of area. Okay. So this is the area that is covered by this particular logistic regression. Whereas for this particular green one, or the SVM, the area that is getting covered is this much. So which one is covering more area? Basically this logistic regression is covering more area, that is this particular extra part, or let me change the color. This extra part is covered by logistic regression. That means it is covering more area. So that's why for this specific problem that we are discussing, logistic regression is the best model. So like that, we can know which is the best model with the help of AUC, whereas which like which is the best threshold, that we can find with the help of ROC. Okay, so this is the use of AUC and ROC curve, and I hope everything is clear in this particular video. If you have any particular doubts, please comment down in the comment section. Thank you everyone. Bye bye.